today we are covering network segmentation. Specifically, I call this session 3 Roads to Network Segmentation. I'm going to cover where we've seen success with segmentation with our clients and kind of review the solutions we've been able to use to segment our clients' networks. So first, the obvious is what is it and why are we doing it, right? So what is it is typically taking a network and breaking that into logical segments, typically via VLANs. However, there's another way to touch on segmentation, which I will cover in terms of one of the 3 ways. So if you're not familiar with VLANs, right, that's a virtual LAN. You can think of a 24-port switch or a 48-port switch or multiple switches. They all come with a default VLAN 1, even if you don't see it. And by default, we're one big happy family, meaning everyone can talk to everyone else. So that's not a great reason for several, which I'll touch on here shortly. But to create that segmentation, typically we're going to go create VLANs, right? Create those kind of layer 2 segments, and then put the clients in the appropriate VLAN. And those VLANs do need to be routed somewhere. So typically there's going to be some kind of layer 3 infrastructure in the environment that is typically either a core switch or a firewall, right? Depending on your size, a lot of VLAN to VLAN traffic, typically a core switch, just to use that high-speed backplane of a switch. Or again, if there's not a ton of VLAN to VLAN, we can be appropriate to route those on a firewall. So the 3 main reasons that we do see segmentation, first one is security, right? As I mentioned, having one big happy family really equates to east-west traffic, right? You might have heard the term east-west traffic. That is being able to talk to other peers or move laterally in the environment versus north-south traffic, right? Leaving our environment to be out to a network or out to a data center. So with the security piece, if we kind of carve up the different clients into those VLANs, then we can route them somewhere. And where we do route them, as I mentioned, core switch or firewall, we're able to do firewall rules or in Cisco parlance, ACLs or access control lists, really limiting the ability to do east-west. Often segments that we do see for security is clients, servers, printers, cameras, access points. If you have any IoT things in your environment, very normal to kind of put those in those different boundaries and then limit access between those. So again, security is a big driver we see anymore, especially with all the security incidents that are in the news, right? Really being able to limit that. And if you do have a security incident, it's ongoing, having those security boundaries to be able to really clamp that down can stop a breach in play. If you're in one big happy family, everyone's in VLAN 1, you really have no controls in the network to go in and try and shut that down without just unplugging the network switches. The second one that I often see is performance. Put network-based because there's a type of segmentation that we're going to talk about today that's not in the network. So the 2 that we're going to talk about that are in the network, performance can also be a motivator for segmentation. When we talk about performance side, we're often talking about quality of service. So this is our good old voice VLAN, right? Once we had a phone VLAN, we put all the phones in that VLAN, we're able to then apply a quality of service across that whole VLAN. So that's a very easy way to apply a quality of service. We can do it at the layer 4, right, based on ports. That's a lot less accurate than being able to do it on a layer 2 segment or a VLAN, and typically takes an enterprise switch to be able to do it at that layer 4. So that's one really great reason is quality of service. The other one is broadcast storms or too many hosts on a single segment. I have walked in environments where there's 1,200 computers on a single segment. Obviously, we're way outside our /24, right? When we do talk about subnetting, that layer 3, we do like to keep that 254 clients and less wherever possible. Again, for broadcasts. So in a normal network, any host is going to be very chatty, especially if you have any Apple devices on the network. And with that, everyone has to listen to every broadcast. So it does take a lot of clients, but I've definitely seen points where we hit a broadcast storm and we start impacting the performance of the backplane of our switches, right? They can only forward so many packets per second, and we have that many hosts all chattering and maybe responding to each other's chatter, right? That can become an exponential problem. So on the performance side, right, quality service and less clients is better in any given segment, especially when it comes to that broadcast piece. And then compliance is the 3rd big reason we see. If we do have any audits that happen, if I have a PCI environment, right, I have card holder data or credit cards, we want to limit the scope of any audit for the auditor. Say, hey, look, this little VLAN over here, that's all that matters. and we don't have to drag in all my other sites and VLANs into that auditing. So that can really save some grief on your side as an IT admin of trying to limit the scope of those audits. So hope that covers what it is and why we're doing it. So the first strategy, which if any of you have been networking professionals for any amount of time, this has been our tried and true for at least a few decades, is manual segmentation, or really trying to build this infrastructure out yourself. So that's you going and creating VLANs, again, on the core switch or on a firewall. And then I included this little snippet here of a Cisco switch, or a good old switch port mode access and access VLAN, whatever that is, right? So my next bullet point, access VLANs in each port. That's going through how many switches on our environment. In each client port, we would do an access VLAN. Access VLAN is somewhat of a Cisco parlance. Other switch manufacturers just call this untagged in their interface. And it's literally like, if you receive an untagged packet, put it on this VLAN once that packet enters the switch fabric. So with that, again, if I have 10 switches, I'm touching all 10 switches. I'm going, hey, port 2 is a printer. Here's the printer VLAN. I'm untagging it. Port 3 is a camera. I'm untagging that. And maybe port 7 is a camera. And all of a sudden, you can kind of end up with a Swiss cheese of access ports in the environment. And again, doesn't scale super well just since I have to manually do that. If you have a very static environment and nothing ever moves, this can be valid. But having done this myself over the decades and having helped our clients through this, you can set it up on a Sunday and it's great on a Monday. And by the next Monday, people come in, do office moves. I don't know why, but having been in large organizations, people love to move furniture on a Friday and just never tell IT. And all of a sudden, the printer's on the wrong VLAN and they broke it. And all of a sudden, it just doesn't work well being such a static nature, especially if we're going to let our clients move around. That next bullet point is really we're kind of inherently trusting the endpoints. I put you on the printer VLAN, I put you on the camera VLAN, I put you on the client VLAN, I put you on the server VLAN, and at no point am I validating those endpoints. So someone could come unplug a printer, plug themselves in, and now they're on the printer VLAN, or more importantly, on the server VLAN, on the camera VLAN. So in the manual segmentation, we are really trusting that, hey, I set that config, and whatever's at the other end of that wire coming off of the switch, that's it's on that segment, right? In that manual fashion. Next bullet point is more enterprise switches do have a notion of port security. So with port security, I can do things like only allow X amount of MAC addresses, right? That should stop someone from plugging a switch in, right? I only expect 1 or 2 MAC addresses. There's also a notion of sticky MACs. So in port security, we can say, hey, that first MAC address that you learned, that should be the only thing on that port, and it should be only on that port for the next few hours. Meaning, if I reboot a switch, it comes up, all my clients, it's going to say, hey, that is a printer, that is a camera, and if you go unplug, go apply and plug in, you won't be able to send traffic unless you go and spoof that MAC address, right? That kind of layer 2 sticky MAC. So there are some things we can do, but that is much more an enterprise feature. If we're rolling with more small business switches or budget switches, often port security is not an option with those. The last strategy we can use to try and secure down this kind of manual segmentation is shut down unused ports, right? With that does stop the office move in the middle of the night, or more specifically, it probably generates an on-call ticket or a help desk ticket, right? Like, hey, we move things around. I know we didn't tell you, but it doesn't work, and now you get a remote in and turn that port back on. So again, manual segmentation, this is where I see a lot of our clients are at. And again, I've done a lot in the past. I think as network engineers, this is just the cheap, easy way. But I think you'd also recognize it doesn't scale super well. And it does add in a certain amount of trust in the network if you're not using more advanced things like port security, which can be their own burden of help desk and management in the future. So dynamic segmentation, really this is the complete opposite of we just saw, right? That is a network engineer, either you folks or, of course, since you're all MNet clients, ask a matrix to do this for you. So with dynamic segmentation, really the root of this is a NAC, or network access control. So a NAC is really kind of going to be the brains or flight control, if you will, for the network for that authentication. So probably the most universal NAC that I bump into all the time, and a lot of our clients already have deployed in some fashion, is the Microsoft MPS, or the Network Protection Server. It provides a NAC interface into Active Directory specifically. I see that most commonly deployed on a wireless network. So if you've ever deployed WPA2 Enterprise, right, that's very much an opposition to PSK or the pre-shared key. WPA2 Enterprise will perform this kind of radius lookup to that Microsoft MPS server. Like I said, that's by far the most common server I see, and typically on the wireless side. I've seen it on the wired side. We do find that clients that do have this deployed often find that it's a bit lacking in several areas, just flexibility, integrations of third party like MDM, and having its own agents. And for several reasons that our clients do look at more robust NACs. To throw out a few examples there, the big ones we see in the industry and have helped deploy is Aruba ClearPass, and there's also Cisco ISE, that's ISE Identity Services Engine. So kind of the two big NACs, and there's a ton of them out there. Again, I only throw those out just as examples of kind of the big players in the industry that we often see. So that's NAC, right? I got to step one of those up. And what a NAC does is it provides a radius interface. This is a very old protocol, but essentially it's an industry standard way to query something. So we stand up a NAC, and it gives us a radius interface. Again, on the Windows MPS side, that's really a radius interface into Active Directory. I should also mention I've seen NACs also used for things like multi-factor on client VPN, right? To get insurance anymore, I hope you guys all have some kind of MFA on your client VPN. Oftentimes a NAC will also facilitate that if it's not built in or baked into your remote access or firewall solution. So we have NAC, network access control. We have radius. That's the interface that it exposes to network equipment, being switches and access points. Then we have 802.1x. So if I want to go authenticate against a server that, or authenticate against one of these NACs, any desktop client is going to have what's called an 802.1 supplicant. So that is, I'm standing in front of Windows desktop, a Windows laptop, a Mac OS, I have Linux. When I plug into an 802.1x port, right? So set up my NAC, I go to my network switch and say, hey, every port, I want to 802.1x, and I'm going to authenticate against this radius server. So once I plug into one of those ports, it's been configured for 802.1x, the supplicant on my desktop is going to give it my Windows credentials, give it a certificate, right? That access point or network switch is then going to go talk radius to my NAC. So just to make these words not as fuzzy, right? NAC talks radius, radius to network infrastructure, then network infrastructure to endpoint is 802.1x, right? So even if you have an Android or iPhone and your enterprise uses 802.1x and you've typed in your credentials, right? That is your mobile device having an 802.1x supplicant talking 802.1x to that device. So again, kind of a broad stroke, that's what deployment looks like. Obviously in the NAC, there's a ton of policy, right? I only want to allow Active Directory users, I only want to allow people in this group, right? We can get granular in there. I did mention 802.1x supplicant. Not everything can run this supplicant. Printers, right? Cameras, IoT things, right? Random Ethernet device. Oftentimes, if we're in an OT environment versus an IT, right? More of a SCADA system or manufacturing. Right? A lot of those things just don't have 802.1 supplicants. It just can't talk that. So when rolling out dynamic segmentation, we will preferably use 802.1x where we can, but if we can't, we use MAC authentication, or really that layer 2 media access control address. With MAC off, we also like to see profiling too. With MAC off, you can actually spoof that, say, hey, this is my MAC address. Most enterprise NACs that I mentioned, leaving out the Microsoft MPS server, have some notion of profiling too. Are you really a phone? Are you really a printer? Are you really the thing that you're telling me you are? Or are you clearly a Windows device that is just trying to spoof, that MAC to allow access to the network? So that is always a consideration, is when looking to play a NAC, what can talk to the 802.1x, knowing that's kind of the gold standard. What else do I need to address in the network? Most NACs, enterprise NACs, can also run some kind of agents to get device profiling. So we can do things like, are Windows updates up to date? Are you running my EDR software? Do you have BitLocker enabled? So on and so forth. Most of the NACs I mentioned, those kind of enterprise ones, do have an agent, or we can also rely on third-party integrations. If you already have some kind of MDM deployed, right, if you already have Microsoft Intune or whatever that looks like deployed, often these NACs can hook into that, and that just becomes another metric. Yes, I authenticated, but maybe my device is out of compliance in some other fashion. I don't want to allow you on the network. With all that said, that NAC can give out that dynamic VLAN. So again, based on device posture, based on group, we can say, hey, switch port, opposed to this manual access VLAN. Now I can do a dynamic access VLAN. After most NAC deployments with our clients, we get to the point where we can remove all that manual VLAN segmentation that we probably started with. That simplifies my switch config and just makes everything dynamic. So if I plug in and I should be on the network, I get on. If I should be on a specific VLAN, I get on. If I'm a rando or someone malicious and I go plug into an open port and I can't authenticate, the NAT can then put me on an internet-only VLAN or a quarantine VLAN. Down at the bottom, I did put SDN. Software-defined networking is another way to handle this outside of NAC. Typically, that's a very large enterprise or campus solution. We're using VXLAN and other kind of overlays and NFV or network functions and firewalls virtual in the network. That's out of the topic of really this webinar and where we see a lot of our clients go. There's a lot of complexity in those solutions. There's some advantages, but just be aware that that is an option. But again, it's typically a very heavy-handed solution. And our third option is not doing this in the network. So the first two options is manually doing it in the network, dynamically doing it in the network, and then there's agent-based. So this has been out for, I don't know, I've probably seen these solutions for the last 5 to 6, 7 years, is more doing this at the host OS or on my endpoints. I have a bunch of Windows devices in the network. There are solutions out there that can go and install agents everywhere, and from there, utilize the host-based firewalls for segmentation. Meaning, hey, I sprinkle these agents everywhere on my servers, on my desktops. I profile them. I can use Active Directory groups or whatever your directory services are. And then that software can either use the host-based firewall built in any modern OS, or bring along their own kernel drivers and do that themselves in the kernel. So in this space, the two players we often see is Lumio and Guardicore, which Akamai acquired a year or two ago. So with those options, again, I have some kind of cloud dashboard. I sprinkle agents everywhere. Those agents will then, check in. The great part about this strategy is that, I get a lot of insight from the endpoint. When I do this in the network, oftentimes I'm like, well, what should talk to what? I can use NetFlow to get a lot of information, right? Who's talking to who that can then give me, some information. Be able to go create those logical groups and create specifically those ACLs or access control lists to limit that exposure of everyone talking to each other. So again, agent-based, I can say, hey, this process is talking to this, and I see it's a database server, and you can start building some dependency tree. Right, do see this solution often fall down is just like our 82.1x supplicant. I can't put an agent on everything, right? So environments that are heavy in the devices, OT or general, I have a bunch of cameras, and at that point I can try and kind of do a hybrid of manual segmentation or agent-based, or I have seen some dynamic and agent-based. As you can tell, there's no one fit for everyone, right? Some of our clients, manual segmentation is just fine, right? A lot of our clients should probably be dynamic, and then a subset, potentially in this agent-based solution. And just like all things in IT, yes, I just covered 3 ways to do this, but there are a ton of other ways and a lot of other products. And I only mentioned a few just in the name of, giving you some education of, kind of the bigger players out there. So other ways that I have seen this done and other solutions out there is an inline solution. So oftentimes this will be kind of on the uplink to the firewall or uplinks between switches or a mirror port or a span port. I'm using inline liberally here. But I have seen solutions that, if I do a mirror port, span port, 2 clients shouldn't talk to each other. We can do like a TCP reset, right, to try and stop that conversation. Or again, if you're more worried about that north-south traffic, right, before I filter out onto maybe solve a old layer 2 or layer 3 network, this is a little more lightweight and generally has more visibility than putting a firewall there. SNMP, again, a little bit older solutions, but there are solutions to where I go to my switch and I do SNMP traps. So anytime anybody plugs in, that NAC using SNMP would receive the trap and then can push via SNMP the ability to do kind of port-based security, right? Again, a little bit of older solution, not as modern as more kind of 802.1x and NAC. But again, just you guys have the other options that are out there. And then ARP spoofing is actually an interesting one that I've ran across recently. We're actually in-house looking at our product that would put an agent on the network and use ARP spoofing or really layer 2 kind of monkeying around layer 2. I guess without getting too technical to either keep people off the network or keep people from talking to each other. So it's kind of an interesting solution. I do find that dynamic segmentation can be a heavy lift sometimes. So I'm always looking at, what other options or protocols are out there to help our clients achieve their segmentation goals.